I design it that way. I think it's better for your education. All right. You are the devil. Poor design. Yeah. Almost made it in the bin. What pen do you want? Just like a blue pen? Is that fine?
Yeah.
Okay. Good catch. All right. Rotations. So now we don't have the origin as our center of rotation. They're giving you a point. So I call this rotations about an arbitrary point. Arbitrary meaning it doesn't matter, right? They tell you what the point is each time. It's different each time. And then we rotate about that. So we're going to rotate about -1, -5, which is here. 1, 2, 3, 4, 5. So there's our center of rotation. So that's where all our L's are going to go to. That's it. That's it. That's the tweet. That's it. So check it out. I don't have to draw an L for that point. Which direction am I rotating? Clockwise. Clockwise is this direction. So I'm going to be rotating this way, the way a clock goes. And I'm going to do it 90 degrees. So if I start horizontal and I rotate 90, how's that going to end up? Vertical and pointing which direction, up or down? Pointing up. So we move that point to here. Let's call that point A. Whoops, sorry. A prime. And the other point A. Let's call this one B. Let's call this one C. Cool, 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 cool. All right, let's go get B now. There's our L. So now we're going to rotate that 90. So we started out horizontal again, but it's going to be 1, 2, 3, 4, 5 in length. So we're going to flip up vertically, 5. 1, 2, 3, 4, 5. They both share the same blue leg. And then 1, 2, 3, 4, 5 in this direction. 1, 2, 3, 4, 5. Is everybody cool with figuring out the direction that that red line is going to go? You got to imagine it swinging up, right? 90 degrees that way. It's going to go this way, not that way. Now we have B prime. It's going to be messy. But we knew that. And then C, well, that's this way. That's C's L. When I rotate that 90 degrees, we're going this way, right, because it's clockwise. So that horizontal blue part is going to end up being vertical and pointing which direction, up or down? Down, right? 1, 2, 3, 4, 5, 6. Down. 1, 2, 3, 4, 5, 6. And that red part is going to swing down here and point to the right or the left? The red part. The red. To the right or the left? The right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now we're going to connect all our primes. I'll do it in pink. Actually, I'll do it in do purple. And there's our rotation. Super gross, but there it is. Cool, 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 cool. How do we feel about rotations about an arbitrary point so far? Not that different than regular rotations, right? Okay. We're going to do one more, and then we're going to jump to the answer key and do something crazy. All right, so let's do this one. 180 degrees. First of all, who remembers the rule for rotations about 180 degrees?
You just have to negate
Negate both coordinates, right? Negate them both. right? Because we're going to switch from double positive to double negative or whatever, right? So that'll be interesting, something to think about. What? It is. So this one right here is going to end up down there. This one right there is going to end up here. And this one there is going to end up here. Yeah. Great. Let's go get this one first. 180-degree rotation, we know it's going to change quadrants, right? So it's going to end up down here. And that makes sense, because if I have a horizontal part here, I flip it 1, we get 90. I flip it again, I get 180. So it's going to go over here. Oh, wait. Oh, no, I did it from the origin, didn't I? Oh, man. Bummer. Try again. Disaster. Absolute disaster. 5, negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is our center of rotation. Ah. Ah. There we go. A little less claustrophobic now. All right, we're horizontal for the blue. When I'm pointing the other direction, aren't I? You guys are backwards to me. So when I go clockwise, or when I go 90 degrees, I'm going to go here, right? And I'm going to go 90 again, and I go here. So I'm going to point the opposite direction it was before. 1, 2, 3, 4. That makes sense. 180 degrees, flat line. Which direction is the red line going to point? Up or down? Down. So I connect it on here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we're there. What? I thought we were supposed to end up in this quadrant. Let's call that point A. Let's call that A prime. Am I crazy? Am I wrong? I'm not. 9, I believe. Yep, 9. Why didn't we end up in this quadrant?
Because when you're going clockwise, it's gonna kind of flip horizontally 90 degrees first. I don't know. But
Notice they don't say clockwise or counterclockwise here. They just say rotate 180. Why don't they need to specify counterclockwise or clockwise? You end up in the same spot, right? 180 to here, 180 to here. End up in the same spot, right? So it has nothing to do with counterclockwise or clockwise. Yeah. All right, let's go get the next one. Looks like this up to here. So that's going to be 11 for the red, and 1, 2, 3, 4, 5, 6. 6 for the blue. So I extend that blue out, 6, when I rotate it. And I'm going to go down 11 to here. I'm going to call that B prime. I know. So this right here is 6 in length. I'm going to rotate that over to here. Everybody cool with that? So before, Jenna, we took this. When we rotated it to there, you were cool with that? No. Okay. So we're going 180 degrees in this direction. I chose that direction. You could have done it down here too as well. Would have worked. So I rotate this way, 180 degrees. That's going to make this guy point down. That's A prime. For B, it's the same thing, right? And then it's going to point down. Better? Okay. Notice how they share the same blue leg before you rotate, which means they'll share the same blue leg after you rotate. Lastly, point C, which is way down here, shares the same blue leg as well, right? Same length as B. If the red part for this, for C, is pointing down, after we go 180, what's it going to point up? Or what's it going to point? If it's pointing down here, after we rotate it, which direction will it point? Up. So there's C prime. And here is our new triangle. Weird. Take some thinking. Try not to get lost in all the lines you're making. If you want, you could take some paper and kind of trace. You can't see it on here, but you could see it like from my view and kind of trace what you're doing. That way you can do one L at a time, and then when you're done with that L, copy down where the point ended up. Use a new part of the paper, retrace, do your lines, put the point, repeat. You can do that if you don't like having all your sketch marks on there. It's up to you. I do them all at once because I've had experience and I can see through them. But if you're struggling with that, I can show you how to do that. All right, let's flip to the answer key. First off, mark your answer key with the points the way we marked them before. Let's talk about the rule. I'm going to zoom out just a little bit. For this one, A, B, and C. Let's copy down their coordinates. So A's coordinates are -2, 1, 2, 3, 4, 5. And B's coordinates are -1, 2, 3, 4, 5, 6, 0. And C's coordinates are 1, 2, 3, 4, 5, 0. Our new coordinates for our primes, A is -1, -4. B prime is 4, 0. And C prime is 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, -11. What is the rule? That's tough, right? This is quite the puzzle. Quite the conundrum. When our center of rotation is not the origin, things get weird. What kind of rotation are we doing here? 90 degrees clockwise, right? From before, when we did 90 degrees clockwise for our homework, which is somewhere down here in the ether. 90 degrees clockwise. This was our rule. Right there. X and Y switched, and we negated the second one, right? That was our rule. Does it work this time? It doesn't. Here's what we need to do first before that works. Because our origin, or our center of rotation is no longer the origin, we've shifted everything over. Imagine taking the coordinate plane, the axes, right, and sliding them onto this. Everything moves with it. Okay? What do I need to do to take my origin and slide it on to my center of rotation? What do I need to do to get that to go here? We're going to slide it. Give me a translation. I'm sliding it to there. One to the left, right? And then how many down? 5. That's all right. Okay. So that's what I need to do to slide it to there. I'm taking everything and sliding it there. I'm just recentering it. Once I've slid it to there, then it should work like this. Because now my center of rotation is this. So we had a slide of -1, -5. -1 to the x, -5 to the y. Let's apply this. -1 to the x, -5 to the y. So here's A. Here's A prime. And here's A double prime. Double prime is where we're going to end up. Okay? I'm putting an intermediate step. I'm going to slide that by this. I get -3, 0. When I flop these, I get 0, -3, and I change the second one. So I get 0, 3. Didn't work. What if I'm not sliding this to this, but I'm sliding this to this? How does that change my vector? If I'm going from here to here instead of here to here, how does that change my vector? It changes the signs, doesn't it? 1 to the right and 5 up. Let's try that. 1 to the right and 5 up. What happens to the -2? -1, because I'm adding 1. What happens to my 5? It becomes a 10. Ugh. Flip those, that's not going to get me anywhere. The goal that I'm trying to present is trying to get these to be the same, because if they're the same, then we know our rule, right? Flip and change the signs. Well, I've tried sliding first and then applying this rule. What if I apply the rule and then slide? We've got options. Our rule says flip them and change the second one, right? So here's A. Let's flip it. What happens when I flip them? 5, -2, but I'm supposed to change this one sign, so 5, 2. Our vector that we were going to apply is either add 1, add 5, or -1, -5. Which one's going to get us to here? Any? Say again? -6, -6? That's not what we want, though. It's not going to make sense. What I want you to do is I want you to figure out how we can map this to this. That way we can use this rule. Do the rest of your rotations, just like normal. I want you to start thinking about these rules and how we can make them make sense. Yeah. I want you to finish all the worksheet. Yep, do all those rotations, get comfortable with them. We're going to talk about that on Monday to make sure we're good. And then we'll review for our quiz on Tuesday. Yes? You don't have to do that? No. That's not part of your homework, but I want you to start thinking about that. How can we get one to the other? I will give you self-development if you're able to figure it out for one of them. This is the tough part. On Monday. Yes. Your quiz on Tuesday won't include the rule thing. I just want you to start thinking about how we can make this make sense, because there should be some mathematical way to get from there to there. I've given you some ideas about sliding this to this, moving everything all at once. This is your hint. It has something to do with that. Order matters. We'll talk about it more talk about it more after break, probably. This is what makes rotations a little bit more interesting. When we get back from break, we'll talk about more interesting rotations, right? Finding the rule with the dilation being, or sorry, not dilation, the center of rotation being weird. And then we'll get into dilations. We'll talk about those, and we'll make those a little weird. And then we'll have a quiz. And then after that, we'll be basically getting ready for finals. Okay? Get excited. Just to be clear, the easy part is the rotation. You guys can all do that. That's what's for homework. The rule you don't have to worry about. I do. Thank you, Chloe. Go.